to know to wipe it off. Clean your jaws, blades, and things once in a while. But it still should be 100% better.
Well, what the hell do they use? Another fruit up there?
Huh? Yeah, but even there, with all this humidity and all, you'll find stuff getting in there. voltage drop to be uncertain or unstable.
She said it was constant oil.
Constant or a lot of surface oxides and your probes aren't sharp enough to pierce them, can cause you to have an unstable reading. But in general, probes are good, meters good, load is steady. We're varying very little, and your voltmeters all over the board. What is it?
Can they help you guys?
The next instrument I would go to get would be the ultrasonic scanner if I was really concerned.
You know, we don't have one of that.
You do.
Ultrasonic scanner?
Barry bought one on my recommendation last time I was here.
Jump it.
Steam traps.
Arcing,
The
right?
heat
Trapping.
arcing, electrical arcing. Digital instability, with all other things being stable, can only be caused by arcing. But if your next move is to get the ultrasonic scanner, you will hear the electrical arcing. Didn't we hear arcing here last time in a breaker or a switch somewhere?
Yeah.
I think so.
Yeah, you have one.
Yeah, I have that little case
Yeah,
there.
we listened to it.
Listening to something arc inside a breaker or a switch.
Yeah.
Yeah, right.
I think you were out front with your wife then, right around lunchtime. Now you all remember. Yeah, but if it's arcing, you can't get a stable reading. Because as those electrons are passing, the meter just won't lock in on it. And then you know it's even more serious than you have arcing. If you then find those two components and get the ultrasonic scan, you'll hear what's called frying eggs. In the trades, when you have arcing, they talk about frying eggs.
Right,
So if you ever get one that's real weird, and you can't seem to get a good reading, don't assume it's the meter. Get as close as you can, knowing that she's arcing. You can occasionally get some fuses banned from the factory. Years ago, I think they checked a higher percentage of fuses as they were manufactured. I don't think they check as many as they do now. I seem to be seeing more and more fuses will come through bad. You'll see a high heat in the fuse body. Now, one thing that will screw you up is, in fuses, 10 amps is not 10 amps is not 10 amps. You have to look at the style. All fuses rated 10 amps in ampacity are not the same. Like ACSLs, FRLs, FRSLs. You can take 3 fuses, all 30 amps, of slightly different style, put them in on the exact same load, and the voltage drop across the fuses will read differently. So what do you have to do there? If you have significantly different styles of fuse, and you've got to get in, maybe one's reading real high, but the fuse is contributing a lot to that, you have to get a piece of paper out and subtract that value, or just split it in half, using the fuses as the middle. Use a fuse blade down and then the line side fuse blade up to take the fuse out of the circuit. Yeah, a lot of times you'll get, if you see a bunch of different styles of fuse in a switch, and you go across them, and one's high enough to worry about, take the fuse resistance out, and that might be it. Fuse resistances change based on how fast you want that sucker to blow, or how slow you want it to blow.
Is that the reason? Is that the reason for all them numbers on them fuses?
Yeah, a lot of people will grab any 330s and keep losing them because the ones that are rated for faster blowing. Yeah, a lot of these are dual element fuses.
Yeah.
They not only do short circuit, but they compensate for overloads, like
That's what
motor
we're
starts.
using.
Like you might want real good protection, but still be able to start a motor. You know, what some fuses will blow at 110% of rating, 115, 135%. You've got a 20 amp fuse that she's going to go at 26 amps or something. You might not be able to start your motors. So they make the link a little bit heavier to act as a heat sink. It takes that original heat from the inrush, and they calculate how many seconds they're going to carry that load. It's the same as a breaker. You know, most breakers will not trip at their rating. Like the 200 amp breaker, you have to go down to the multiplier, where you have that little multiplier, 1 to 5 or 2 to 10. And if they're set higher than 1 or 0, and you're not running to the frame, and you just change the instantaneous. You can run breakers 5 times higher than their rating. Just put it on number 5 setting. Now you're 5 times the frame. So now you're 1,000 amps for instantaneous. Because you may have a motor that only draws 120 amps, but it takes 200 to get it rolling. It keeps tripping the breaker. So you kick up that. Yeah. Goose it up a little bit. Yeah, but fuses, 3 different styles of fuses will all read different in voltage drop.
That's why you need constants, yeah.
Need your constants in there. Yeah, all things have to be the same. Shit, I think most of your renewable links, when they're rebuilt right, will read lower than most of your dual element fuses or your one-timers. There's only that little single link in there with a bunch of notches in it. The only advantage the one-timer has, they're factory brazed versus bolted together. You guys know, put a little grease on them, tighten them down real quick, you'll get real good readings on those.
All right, what's your location? Your office.
Yeah, guys that successfully use renewable link fuses are also using a digital multimeter religiously. They don't just rebuild the fuse, it looks good. It also has to test it.
I know where a hot fuse is, just a little fuse in here.
Got it on your list?
Wasn't on the list. I
I'm gonna
just
go
felt
bang that sucker out Saturday.
I just felt it the other day and it was pretty hot. If you want to go take a shot at it, we're getting rid of it anyway.
You also have fuses that run hot. There are some fuses run hot as a bear.
This is pretty hot.
This guy.
Well, I don't know. Maybe we should go up to the other transformer. Yeah. See what
Yeah, okay. Yeah, that's not the case. I'm doing away with this anyway. Or it wasn't like.
You have your voltmeter now to test it.
Yeah.
Okay.
On?
Yeah.
When the available short circuit current exceeds the ability of standard breaker contacts to quench the arc, they back up the arc quenching capability of the contacts with fuses. So when you pull this cover, unless there are solid bus in there, which they have adapters, you're probably going to find fuses. Most important thing is how careful you are when you pull the cover. That determines how dirty your knees will get later. Because there's a 4th trip device. Each of these fuses has a tit that pops up. There's a gang bar that comes across, a common trip bar. The fuse blows, a spring shoots a contact out, hits that bar, and causes the breaker to trip. So in whatever pole that's faulted, you're trying to break the arc in 2 places, inside the fuse body and up at the make and break contacts. Anytime you try and break the arc in 2 places, it's twice as easy. 3 places, it's 3 times as easy, because you've divided the magnitude of the fault by 3 times. But there's a 4th trip device on most of these.